Good afternoon and hello to all. Thank you, Praveenji, for introducing. So, today we're gonna start our presentation and we want to address what are the two major challenges that any chemical and petchem projects face with respect to the schedule and investment. So, before we start any project, the major challenge for any end user is how they can minimize the schedule and how they can minimize the investment going along with that schedule. And that's what we are going to address from different aspects. Let us first do it in the field. So in field, it all starts with a chemical reaction that needs to be controlled and monitored. How do we do that? We do that by putting up instruments and putting up cables, junction boxes, cables that are connected to the IO modules in the field, and then we monitor and control it through the controllers and the distributed control system. With this approach, what are the limitations that has? Because we need to first design the process, we need to ensure that we have the right instruments, we have already planned for it, we need to ensure that the field schedules are done, and we need to make a lot of assumptions. Since in the beginning of the project, we do not have a lot of information about OEM's kits. We do not have a lot of information about the products that may change or how the molecules are going to behave. So this causes the project inputs and the process to change from time to time. And because of which, when we further bring it to the level of control system, there are costly changes that comes up at the later stage of the project, as this leads to a lot of change orders as well. Further, if there is an additional capacity expansion, additional changes that needs to be done, we need to again go back to the field and start back from the field to lay the cable, find out the space, find out the cable tray and everything. How do we address this challenge? This challenge can be addressed by moving the IOs to the field as shown here. Earlier, this IO was placed in the control room. Now it has moved to field. What has happened in this case? In this case, the cables that were there earlier, the kilometers of multi-core cables that were connected from junction boxes to the control room, they have got totally eliminated. That was not just about the cable. Apart from the cable, you also had the cable tray, the structures for the cable tray, the termination activities that needed to be done, the loop wiring that need to be checked, which are all time-intensive jobs. So all of that you have reduced by a significant amount by shifting the IOs in the field. Further, if we go ahead, what happens if something comes up in future? You can easily add a remote IO, a cabinet in field, and take care of the expansion as well. You don't need to worry about, oh, I need to again lay a lot of cable from field to the control room. Where is the space in the cable tray? Do I need to put more cable trays? Whether there is space in control room. As you see further, the late changes. If there is change in IO type, if there is a change in process that needs to be accommodated, all that can be done by simply swapping out the IO cards in the field. That was earlier there. But in earlier case, you had to again search for the space, the spare space. Further, because of the assumptions that we used to do in the traditional approach, there was a lot of contingencies that were being built in. So you would need to go for spares up to sometimes 30%, 40% that some of the customers have asked us to consider in the first instance of the project. And that comes down a lot when we are able to go with this approach. Further, as you see, there is a lot of space in control room that is saved. Now, you don't need to build large control rooms which will have tens of marshalling panel because all the marshalling has already shifted to field. It is only the controller panel and the operator stations that we need to put. So that's how we can address this issue. Further, there is absolutely no impact on system reliability and the availability that is available with this concept. It may come that what happens if it is shifted in field, whether the IO cards can handle that harsh conditions of the field. Let me assure you by saying that this is already being done and we already have different sets of IO series that can cater to the higher harsh climates and series. So first is if your chemical plant is a safe area plant, we can put S800 IO series of controllers, of IO cards. Similarly, if you have zone 2 field, we can again go ahead with S800 IO series, which are again certified for zone 2 hazardous conditions as well. Further, in case of zone 1 area, we can go with S900 IO series, which are IS intrinsic cards and they provide intrinsic supply to the field. That's how we can come to the conclusion that this solution is quite tailor fit and it can meet the dynamic demands of the chemical industry, which causes the products to change, your recipes to change, your equipments to get added, and it is quite easy to scale up your plants and increase the production in future. Further, what are the specific advantages of going with ABB remote IO solutions along with ABB DCS 800XA? Let's look at it. Your engineering is plug and play. You don't need to worry about the GSD files import of a third-party IO card, whether the third-party vendor will support or not, how many years they are going to support. You have a unified life cycle support that you have. Your total cost of ownership also comes down with it. Further, all the benefits that you used to see in a traditional IO concept and control system, all that is available even with the remote IO solution as well. So why don't we go for it? In fact, a lot of the customers here in Gujarat itself, you can understand, have already gone with this concept. In fact, we are already implementing with one of the major clients in Gujarat cluster as well. These are only some of the major logos that we have put up. And this solution has enabled them to come up with their plant and bring their products to market in a very short span of time. So, with that, we covered the first step, that is the field. What can be done in control room? In control room, typically, if you go, today's scenario, you will see a lot of workstations that are there. In these workstations, then there are a lot of servers that is to be put for the operation of those workstations on the operation of the DCS. But if you look at the utilization of each individual machine, it's hardly 10%. Why don't we try and utilize this to the optimum level? What is stopping us? Now, with virtualization, DCS on a virtualized system, we are increasing the CPU utilization from 10% to more than 60 to 70%. As you see here, the string of servers that you see in the first graphic has now reduced only to 2 servers. Virtualization is not a new concept. It is already known and it's widely implemented in any of the cloud platforms that you use or any solution that you are using. However, its acceptability in DCS was still limited till now. But with ABB DCS, we are able to provide the virtualization and virtualized concept seamlessly integrated and with seamless performance with the advantages as highlighted. How it is future-proof? Even today, since the hardware is decoupled in case of virtualization with the software, you can take care that some of your systems are still working on the legacy OS. You can have Windows OS system, Windows XP, along with Windows Server 2022 in this virtualization. So earlier, when you were upgrading, you would have a thought of whether your hardware is compatible or not. But since you have decoupled the hardware with software, that worry is gone. You can even on the old hardware with virtualization, you can put the latest servers, which allows you to go for upgrades and updates even with the latest systems. Further, other benefits are also mentioned. Another one which I would like to pick and highlight is on the operator station. In today's scenario, when you have a full client, a full workstation that the operators are using, what happens when that goes faulty? You need to depend upon the IT vendor to bring the workstation. Then you need to depend upon the hardware OEM supplier of the automation to install and configure and make it run. There are so many dependencies. But with virtualization, as you see, those workstations are replaced with dummy machines called thin clients. Now, the beauty of this thin client is, if this goes faulty, you just need to bring another thin client, which can be a spare machine, and you just need to connect it to a network and log in. There is no installation, there is no other configuration that is needed. So, what is the effective downtime? Maybe 15 minutes, 20 minutes, half an hour? So, the downtime is reduced greatly with this system. Further, let's say even if a redundant server has failed, with virtualization, it's quite easy to take an image backup of the complete machine and then restore it within hours. So you do not lose any availability or downtime in your plant. These are some of the references that we have. This is a technology which has been existing since long for the DCS. But as you see, the acceptability of this technology has increased from 2012 to 2024 by the look of the density of the projects that we have been executing with this solution. Forgot to mention, at the corner, we also have a QR code, which you can, if you like any part, please scan and you can put your queries and we'll get back to you after the presentation. So that covers the control room as well. Now, we have minimized the time and the investment that goes during the project phase. How can we achieve operational excellence? So let me give you a scenario. This looks like a typical alarm screen or an alarm window on any DCS control room. But it is also not so typical, because typically if you see, this alarm screen would have hundreds of alarms. An operator needs to juggle between hundreds of alarms. And that is why the operator doesn't even look at the screen, they rather will look at the operation window, at the process vessels. However, let me look and click at one of these alarms. With this single click, the operator goes to the exact graphic where the problem has occurred, from where the alarm has come in. Simultaneously, even the trends are open. The alarm instructions, what operator needs to do in this case of alarm, even that is available along with the faceplate to allow him to take further action on this error condition. So, do you feel this is helpful? Now, with this solution, what happens? The operator gets the focused information that is relevant to him, and it is not, he doesn't look at the causes. The alarm that you saw was not the cause, was not the effect of that, but it directly takes the user to the cause of what caused that condition in the plant. Let's say you have a valve whose feedback doesn't come. Because of that feedback, your pumps doesn't come, the pump trips, your level sensors or your pressure or your temperature goes down, or it may go up. Now these are the causes of what? Because the feedback doesn't come. With this process, we don't highlight what are the effects, but we went and go to the root cause, and that is available to the operator in an instant with a single click, which he can then resolve. This is what is known as exception-based operation, and this is what's called the traditional way of operating a plant has shifted away from you looking at the graphics for long hours trying to see everything is working smoothly, to the part where he only focuses on any issues or alarms, prioritized alarms that have come up. And with this concept, we have been successfully deploying since 2018 and has been deployed across major names that will come up in the next slide. You will be quite surprised which of the customers that are using this. This actually allows the operator to only focus on the critical sections without worrying about the normal day-to-day actions in the plant. Further, this reference that you see is a 50,000 IO. 50,000 IO, you can understand how many instruments, how many reactors, and this is run by a single shift operator using this technology. Some of our major clients who are utilizing this solution, you can see Asian Paints, Birla Opus, Deccan Fine Chemicals. And with that, we come to the third topic, operational philosophy, and how we can increase the operational efficiency by changing the operation philosophy of the plant supported by the technology. With ABB, by transforming the way the CapEx projects are done, we are able to reduce the CapEx saving, provide a scheduled compression of the projects, and also reduce the startup hours as mentioned earlier. And all the methodologies, the technologies, infrastructure, and the capability that enables this to happen have been mentioned and shown in my slide. Hope you found it useful, and request you to kindly reach out to me and other of my colleagues who have also put up a stall here in the booth here in ground floor, and visit us and in case of any query and if anything seems of interest to you. Thank you very much.